In this video, I will show you how to create accurate shape and dimensions of the PCB according to a manufacturer's datasheet. And I will show the usage of grid, origin, snap points, guides, and measurement tool. This is a datasheet of this enclosure we will be using, and it contains also a 3D model, but I will rather use this nice schematics of the shape of the PCB with all the measures. Measures are in millimeters and inches, and they are not round, so it doesn't matter whether you use inches or millimeters. I will rather go for millimeters anyway. So first of all, I will set the grid. And grid, well, I would go for 1 millimeter for a start, and we'll see if we have to change it or not. So the grid can be set by pressing letter G, and I will set the grid of 1 millimeter. Okay, the next thing is the origin. The origin can be placed everywhere, but actually in this case I would rather place it in the middle of this PCB, because this PCB is symmetrical left to right, so I'll place it in the middle, and then these dimensions will be easier to set. So I will go here and I will use the function edit origin set, and I will place it somewhere, let's say here. Now the origin is placed here, and I will now draw some guides around this origin according to the measures in the datasheet. If I click somewhere outside this, anywhere on that empty area, I can go to properties, and here I will have a guide manager. And in this guide manager, I would add a few guides, some horizontal and some vertical guides according to the measures of the PCB. So here I would like to mark the corners of this PCB, so the top and bottom edge and these two corners, which actually according to the measures are a little bit different. Okay, so first I will place the horizontal guide, and I will set its measures to, I would just put it to 0, so it will be on top, and that from that on I will move downwards. So the next horizontal guide, I will just add it here, should be placed at the position of 78.18 millimeters, and minus, of course, below minus, clicking here, minus, enter, here. Okay, now the vertical guides. The width of the PCB is 67 millimeters, so I will add 2 vertical guides. One would be minus 67, half is 33.5 minus, and 33.5 plus. Okay, now I just have to put another 2 vertical guides. 1, 2. Because the other dimension is 60.78, which would be then 30.35 plus 4 is 39, and minus 30.39. Okay, now I have the outer dimensions, the PCB. And the next guide I will also put horizontally is the guide that determines this position here of the notch. So going back, I will add another horizontal guide, add horizontal guide, that would be placed at 22.74 minus, of course. Okay, now I'll draw some lines. I will go to the mechanical 1 layer, which defines actually is used for defining the PCB border. Click here. I would use line width of 0.5 millimeter so that I can see it easily. And first I will place this here. Now I would like to snap to these guides. So I will click here and I'll use the snap to guide. Okay, I will now place this line. Okay, that was quite easy. Going down, placing that one as well. According to the guides, now it's very easy to place it accurately. Okay, what about this curve here? It's actually an arc. That arc has a certain diameter, and its diameter is 357.35 millimeters. Okay, so I will place arc. I will start arc edge, starting here and finishing there, placing, of course, it correctly. Now the diameter of this arc, of course, should be changed. I could also change it like that, but I'm not sure if I did it correctly. So I would rather set it in, type it in directly. So properties, arc radius should be 357.35. Okay, it was not really good. Now I should put it here and try to set the points correctly. I'm not sure how to start, so I will start just somewhere and I will extend it till here and till here. All right, so here it might be just to right, but here it's just not correct. Let me put it directly in. Okay, so here it's not meeting the other line, so I have to put it in halfway. So I'll put it in halfway, something like that. So now on the other side, it should go down to meet the line here, this guide here. I think I will manage now to fit it correctly. Okay, it's in. Now going there. Let me see if I will meet it. Not exactly yet. So I was just too far. So I will now meet halfway again. Increase it a little bit, and I will do that iteratively until I meet it completely. Okay, I think I will manage to fit it now. All right, not yet. Okay. So it will take some time. Move it down. Of course, I can use smaller grid, maybe 0.525, and try to fit it as well as I could. Meeting it halfway near. I'll try to fit it completely. Okay, going down again. I think I showed the point. It's not exact, but it's good enough. Now I will also add another. Here I have to add the notch. Again, I will go to the browser here, and the notch, which I would have to add, has a radius of 3.16, and it should be placed exactly here. So I will go and place it here. Place arc. I will just place something, whatever. Okay. And I will set the radius of 3.16, and the start angle will be 360. Now it would be actually, start angle would be 90, and end angle would be 270. Let me see. Yeah. Okay. And I will place it on this here and mirror it. Okay, how far within the PCB should it be placed? It should be placed 8.29. So let me move this. I will go to properties. This vertical is placed on minus 33.5. Now I will add another vertical guide, add vertical guide. It should be placed at 8.3 less. So 33 minus 8 is 5, and minus, of course, minus 25.2. Okay, so I just hit it accidentally directly at the spot. So I'll place line here and here. Okay, what else? Well, then I have to copy paste this arc, and I will have to move this one to that point, and another one just move the end points so that I can fit it to this guide here and here. Okay, now I just move this side, completely select everything and just copy and go to the origin and paste it, and I will mirror it on x-axis and paste it directly, and it should fit perfectly. So now I set the shape of the PCB. I can select all the features and just select design, board shape, define from selected objects. Yes, and now my PCB is defined. What about the holes? Where for the mounting holes I have to put another guide, and I will set it so according to this dimensions here. So the top are 5.8.11 and the bottom 5.6.96. Okay, let's do it. Okay, shall I use new guidelines or shall I reuse the old ones? Maybe I don't need these guidelines anymore, so I will just move them. So these two vertical, which are the outer ones, I will just move them in. 5.8.11 divided by 2, it would be 2.5 plus 4 is 2.9 point something, like minus 2.9.05 and 2.9.05. Again, these are the outer, and the bottom mounting holes are 56 apart, so it's 2.8. So I'll use this to 2.8 and minus 2.8. 2.9.05, right? Okay. So, and these holes are 40 millimeters apart vertically. So I will use maybe the top horizontal, and I will move it downwards for maybe 10 millimeters, minus 10 actually, but yeah. And the other one would be minus 50. Okay, I will put my pad here. Place pad. Okay, the pad should be defined. I will start with designator 1. I will set the hole size 3.2 millimeters, which is already set actually here. The hole size as well, and the X and Y axis. The round shape is selected, round also here, and some rules. I will set the manual rules here for the solder mask, setting the outer solder mask expansion on top layer to 1.5. And on bottom layer I would set to, I will unlock it, set to 0.2, so that you have separate wider solder mask expansion where the head of the screw is. Okay, and I will just place it on this these two should be a little bit more apart, like that. That one here. And these two should be a little bit closer here. And here. The only problem is that actually these holes are not defined how they are arranged vertically. If you look here, there is no dimension shown here what is the distance from the edge to these holes, or anywhere actually, which is quite a pity. So I have to use a 3D model to define this and try to align the board with the 3D model. So I will now place the 3D model here, place 3D model, 3D body. I will select that one and I will place it to the position. Okay, 3D models are hidden, so I'll have to unhide them. I can show 3D bodies by going to View Configuration here and select 3D bodies. Okay, that's the 3D body I just placed. Let me look at it in the 3D. Oh, the 3D body contains all the features in the same file, so I cannot see anything. I can of course move it, and I would actually see something when I move it, but it's quite hard. So actually what I have to do, I will make it transparent. So I can click on the 3D body. Now I think it's selected, properties, and I will select opacity to maybe 25%. Okay, now I see it quite well. Before aligning it, I have to set the snap points. So I will use these tools, 3D body placement, add snap points, clicking here and try to set the snap points to these features, holes, and these openings, whatever I want, anything that I want to mark. So doing that, I set the snap points, going back to 2D. Okay, I have some snap points here. These are the ones which I actually want to use. Okay. I have to align the center of the 3D body to any location but that's the problem of the 3D body, because I cannot find the center point, but I can set the center point here. So this arc here and that snap point should actually coincide, and they do now. Okay, now let me check here. This snap point actually defines the snap point of the 3D body. Here should be aligned perfectly with this vertical line, which now is. And now I can move these four mounting holes to these snap points. Okay, so I'll select these 4 mounting holes, maybe not all of them, just these 4. Maybe I can do it like that, left to right, and press shift and select these 2 as well, like that. And I will move them so they can snap to this snap point here. Okay, I will try to grab them in the middle. Okay, and snap here. It's not perfect, but I think it's good enough. Okay, by that I can hide this 3D body snap points, and by that the PCB is well aligned with my 3D body, and it seems fine. Now I can check these measurements by using Ctrl M. The Ctrl M is a measurement tool, and I can use it to measure different distances between different features. So 56 millimeters seem fine. What about here? 40 millimeters, almost. Did I miss it? Yes, I missed it a little bit. Again, I will measure it again. It should be 40 exactly. It is 40.01. Okay. And other width, like here, this width with respect to that one. Okay, 66.96, 67. And so on and so on. By this measurement tool, you can check all the measurements. Shift C would delete all these measurements. Well, at the end, if we wanted to use this 3D body to actually define the shape of the PCB, we had to import it in a 3D editing software and divide it into different parts like top lid, bottom lid, and and plates and all the stuff. And you would actually find within a 3D model of a actual PCB. So there was one, and maybe we can also access it in Altium. We can of course zoom in into this 3D body until we get inside of it. Okay, I think now we are inside. And we can use this function design, board shape, and define from 3D body. Click on 3D body, move the mouse around, and now the 3D body of the PCB itself is selected. And that's really nice. Clicking it, do not modify position, close, and we get the 3D body, which is of course very, very easy and useful. Now I just have to find this dimension of the top part of this PCB and cut it off, and a few tens of minutes of work would be spared because of this feature. So that's it. And using guides and all the other tools makes your life easier when you want to define a very precise dimensions of the PCB or any other feature actually on that PCB. And that's it.